effects of decaf or regular spent coffee grounds compared to store-bought fertilizer on basil plant growth. Before we start, here's a little about me. My name is Miranda Uriostegui. I'm currently a senior at Galileo Magnet High School, and I will be attending ODU this fall in order to pursue a career in criminal justice. My topic was chosen with the consideration of my grandparents, who before moving to the U.S. had a small family business in their hometown in Mexico. They now continue this family business through local farming on the eastern shore of Virginia. This has inspired me to find ways to aid local farmers who face problems such as poor soil quality and expenses, which can be aided through the study of alternatives for expensive fertilizers. Along with the personal importance of my study comes the relevance of it to the world as well. A current problem that we are all facing is climate change and global warming. Global warming and climate change are caused by human activities such as deforestation, pollution, and waste production. One of the most produced wastes is coffee waste. As the production of coffee is in higher demand, the amounts of waste created during these productions is increasing and causing environmental concerns. Another factor that I considered after speaking to researchers in this building is the rising concern of chemical pollution in our environment. This includes our food, water, soil, and many non-essential and essential products. Although the use of chemical fertilizers isn't the only problem, it is a factor. Therefore, this study focuses on the use of these waste materials in a beneficial way to our environment. Before conducting my study, I educated myself on waste materials and their current impact on our environment. I learned that the continuous consumption of coffee waste has produced overbearing amounts of coffee waste which have played a part in environmental issues worldwide. The most relevant are SCG, or spent coffee grounds. Past research has confirmed that finding alternatives such as using them as compost for plants and soil can diminish their negative environmental impact. Overall, agro-industries such as small local businesses and trade organizations could benefit from the use of these waste materials as fertilizer. Now, some may ask why I chose to use SCG. Spent coffee grounds hold natural benefits which can organically enhance the production of plants and the health of soil. While on the other hand, inorganic fertilizers contain many unknown or artificial ingredients. Inorganic fertilizers aim to contain specific nutrients that are good for plant growth but have shown to have slight or negative effects. A prior study states that the continuous and unbalanced use of these chemical fertilizers is the main cause for declining productivity. The questionable effects of chemical store-bought fertilizers, the easy access to organic coffee waste materials, and their abundance are all factors that led to my decision on using SCG. Moreover, coffee grounds contain phytochemical properties that benefit soil fertility and water retention, along with nutrients that are necessary for plant growth. Studies show that SCG is a resource for several high-value products such as oils, proteins, minerals, and fatty acids, and most of its effects on plants are due to its abundance in carbon and nitrogen. The gap in my study was the use of basil and the use of decaf coffee grounds. Prior studies have used plants such as tomatoes and lettuce, while I chose basil, an herbaceous plant that has many other benefits and is commonly used. This created my gap. When deciding the variables being used in my study, I decided to include decaf spent coffee grounds in order to expand the gap being studied through my research. As stated before, among the studies that I researched, it was revealed that SCG had the right phytochemical properties to fertilize soil and improve plant growth. Although these studies had detailed and positive results, the variation of plants studied is minimal and could be broadened through future research. My study will be answering the question, what are the effects of decaf or regular spent coffee grounds compared to store-bought fertilizer on basil plant growth? My null hypothesis stated, if organic fertilizer is added to basil plant soil, then the plant will show no significant change when compared to plants with other or no fertilizers. Furthermore, my research hypothesis states, if organic fertilizer is added to basil plant soil, then the plant will show greater height change when compared to plants with other or no fertilizers. The dependent variables of my study included the height of the plant, and the independent variables of the study were the types of fertilizer. These were store-bought water-based fertilizer, decaf coffee grounds, and regular coffee grounds. My constants included the light, water, soil, environment or location, and the plant type. And my control of the study was no fertilizer at all. The population of my study was all basil plants, while the sample was the basil plants that I studied. My sample size was 40 total, and the main materials used were basil seeds, water, grow light, water-soluble fertilizer, regular coffee grounds, and decaf coffee grounds. First in my procedure, the soil, fertilizer, seeds, and coffee grounds were all purchased. When preparing to plant the seeds, I randomized my sample by numbering each plant cubicle in the tray 1 through 40. Then I generated a random number to decide where each seed would grow. After randomly placing each seed according to the instructions on the packet, I created my mixtures. The solutions were a teaspoon of fertilizer dissolved in warm water, a teaspoon of decaf coffee grounds dissolved in warm water, and a teaspoon of regular coffee grounds dissolved in warm water. And lastly, the control was just water. 10 of each solution were made. Next, I named each section of the tray a random group to distinguish the treatments. Since each column contained 5 cubicles, 2 columns were used per group. Finally, each mix was added to each plant, and the grow lights were placed over the plants. Next, pictures were taken. This process was repeated every 3 days in order to observe progress, and lastly, statistical analysis was conducted. The graph shown displays the final data of the growth of my basil plants while using the 4 different treatments described in the procedure. The height of the plants was measured in centimeters, shown on the y-axis, while the 4 treatments are shown on the x-axis in the order of fertilizer, decaf, regular, and control. The box on the graph highlights the area containing the tallest plants of the sample. These plants are a part of the decaf group. This shows that the decaf treatment provided the best results in the basil plant growth. On the other hand, this box highlights the shortest heights, which are a part of the control group. This shows that the control group of only water provided the least effect on the basil plants. Lastly, these boxes show the close results of the fertilizer treatments and the regular coffee ground treatments. These means were very similar and have the same tallest and shortest heights. These groups contain wider spread data, which means that they provided different effects on almost all of the plants. After using an ANOVA for my statistical analysis, I found that at the significance level of 0.05, the null hypothesis was rejected with the p-value of 0.01. A p-value that is less than or equal to 0.01 means that there is an extremely strong confidence that the groups are different. This means that there is sufficient evidence to support that coffee waste treatments and fertilizer treatments test significantly different on basil plants. Along with the rejection of my null hypothesis, my research hypothesis was supported by my results. The results of my study concluded that spent coffee grounds work better than fertilizer. Based on the studies I previously researched, I inferred that spent coffee grounds would provide faster results on basil plant growth when compared to store-bought fertilizer. This led to the formation of my hypotheses. These studies emphasize that coffee grounds' natural properties outweigh the effects of artificial ingredients in store-bought fertilizer. Although my research hypothesis was supported, my conclusion specifically indicates that decaf spent coffee grounds work the best. The research that led me to my hypotheses were all specific to regular coffee grounds, and which led me to the gap of using decaf coffee grounds in my study. These results were unexpected, and I believe that these results may be due to the fact that decaf coffee grounds have a smaller dose of caffeine in them. A 2022 study that I analyzed stated that caffeine has positive results on plant growth, but can easily be overused in larger doses. The results of my study identified the best alternative use for waste materials, which are increasing numerously by the day. These findings can be implemented in industries and other more local communities that may need these materials for daily use, such as for farming and agricultural studies. The results of my study specified that decaf spent coffee grounds may be the most effective for faster and healthier plant growth. These findings are filling a specific gap, which means that I could not find much research or information on the possibility of decaf coffee grounds having better properties than regular coffee grounds. The limitations of my study included lack of time, which could have allowed the plants more time to grow. Studies I have researched showed that better results were found over a course of a year or a whole summer. Another limitation is the environment in which my plants were grown. Due to the fact that a greenhouse was not used, the grow semi-stable temperature and amount of light. This may have contributed to the significant difference between the plants towards the sides of the tray rather than the ones on the middle, since the grow lights were placed right over the middle of the tray. In future research, it would be best to occasionally rotate the tray or the lights in order to apply an even amount of light and temperature on all of the plants. Lastly, human error could have affected the measurements of my mixtures. This could have been avoided by using a more precise tool. Moving on, the research done on spent coffee grounds is mostly in comparison to other composting methods, but usually done using the same plant types and soil. This research should be broadened by testing other plants in different soil types, such as drier soil or fruit. This could show how diverse and useful waste materials can be, or could be used to compare negative and positive results in different environments. Finally, our senior research projects are long drawn-out processes that teach us patience, grit, and even new skills. Along with the newfound knowledge of our research, I learned a lesson the hard way. After completing my research and transferring my plants onto my back porch, I learned that deer have a taste for basil. These pictures show my baby basil plants right after being transferred to their new environment. Now these pictures show no plants, but pots in a mess created by hungry deer just that night. I would like to thank Piedmont Governor School teachers Ms. Dillon, Ms. Gravitt, and Ms. Long for their advice and guidance, and I would also like to thank Mr. Whitaker from Galileo for showing me interest and encouragement throughout my process while helping me with my research and procedure. Thank you for listening to my presentation. Are there any questions?
I was wondering, you had a picture of a coffee can on in your slides, but you didn't use fresh, uncooked coffee. You used cooked coffee, like you boiled it or whatever. You went through a process that was used, right? Is that correct?
Ms. Walls asked how my coffee grounds were used. I did not brew any coffee with them. I just made a mixture of the coffee grounds with water in order to mimic what spent coffee grounds would look like when produced with big organizations.
Okay, so then my follow-up question is, do you think that you would have achieved different results if you had actually used coffee grounds?
I do believe that it would be different, since after brewing there is different. It would have different properties.
Okay.
So you talked about kind of how you measured how did you measure the amount of coffee, and how did you try to keep it consistent between the soluble fertilizer and the basically coffee ground solution? Did you use volume? Did you use mass?
Mr. Talarico is asking how I measured the amount of coffee grounds and fertilizer used in my mixtures. I measured out a teaspoon of each and mixed it with about a milliliter of water for each plant. So every plant received the same amount of treatment.
I'm sorry, I may have missed this. Where did you get your recommendations for your measurements?
Ms. Collins is asking where I received the measurements that I used. My measurements were inspired by a study that I analyzed at the beginning of the year.